So second slide, এখানে আমার রাইটে আমার সম্বন্ধে I'm not going to read those. So left side আমার কন্ট্যাক্ট আছে, আমার ব্লগ থেকে আপনারা কন্ট্যাক্ট করতে পারেন। লিঙ্কডইন, টুইটারে আমি অলমোস্ট অল ডে আমি টুইটার ফলো করি, একমাত্র সোশ্যাল মিডিয়া যেটা আমি ফলো করি। প্লাস আমার ডিরেক্ট ইমেল অ্যাড্রেসও আমি দিচ্ছি, সো আপনারা ওইখানে আমাকে কন্ট্যাক্ট করতে পারবেন যদি আমি কোনো কোশ্চেন আজকে অ্যান্সার না করি বা কোনো কনফিউশন থাকে প্রেজেন্টেশনের পরে। সো আজকে আমরা যেটা টপিক সেটা হচ্ছে ইন্টেলিজেন্ট কোয়েরি প্রসেসিং। আর ইন্টেলিজেন্ট কোয়েরি প্রসেসিং সিকিউএল সার্ভার যারা ইউজ তারা যদি 2017 বা 2019 যদি আপনারা ইউজ করেন, then you might have seen it was first released in 2017. They called it adaptive query processing, and in 2019 they took those 3 features and added 4 more, and altogether they call it intelligent query processing. Why do they call it intelligent query processing? Because you can use all this feature without making any change on the front end. So these are some challenges. These are not new. Developers had been facing these challenges for many years. So finally Microsoft put some attention into these things to how to solve this. And they know that, sometimes changing your code or refactoring your code, it's easy to talk about, but it's not easy to implement, right? Sometimes we have third-party softwares that you buy that you have no control of, how they wrote the code, how they wrote the stored procedures. In the previous speaker was I think you guys were talking about using ORM, so how the code is automatically generated that you cannot do anything. But now just by switching to a newer version, those codes will act differently. They will execute a lot quicker, better execution plan. So we'll see some of this during the demo too. So why did Microsoft finally decided to tackle these things, right? So just to give you some quick background, and this itself can be a talk for a whole hour, that once we submit a query into the SQL Server query engine, how does this work? And I'll mostly talk about, the whole talk is about SQL Server because that's my expertise. I've been working with SQL Server for many years. I did work with MongoDB for about 4 years, but I don't use it any further in my current place. So most of my time is spent SQL Server either on-prem or in cloud. So as soon as we submit a query, first it goes through a phase called parsing. So you try to build a logical tree to see that if your query is making sense. During parsing phase, it even doesn't check if those objects exist. So if you put a table name that's not in the database, parsing phase doesn't care as long as the structure of your query makes sense. The second phase is transformation. So in transformation phase, it checks that if all the objects are present. Also, if you say, for example, if you used a view, it will replace the view definition, the view name with the correct definition. And in transformation phase, it actually looks at different combination of trees, right? So like if you do a join between 5 tables, you can literally execute that query by 2 to the power 5 different ways. So that's a huge number, right? 2 to the power 5 is probably, I don't know, probably 128. So after the transformation phase, it goes to cardinality estimation, and this is very critical. During cardinality estimation phase, what SQL Server does is it goes and looks at the histogram, and it looks at a couple of heuristics and try to estimate how many rows will qualify for each operator, and then it gives a cost. Now, after adding those costs for each operator, the query plan gets a cost, and at this time, SQL Server compare different costs. That's why SQL Server query engine is called a cost-based optimizer, because it's always looking at the cost. How much is going to cost? And when it says cost, means it's a CPU and memory and IO, a combination of these 3 things, right? So the lowest cost wins, and that plan gets choose to execute. As soon as that plan gets choose, they put this plan into the cache. Why do they do that? So next time we call the same query, or the query looks same, even though you can pass a different parameter, SQL Server doesn't have to do this first 4 phases. And how does SQL Server compare this? So every query we submit, it creates a hash. So next time the same query come, it says, okay, this is my hash. Is there a plan for this query hash? Yes. So then it doesn't have to do the first 4 phase. It and from the cache and go and execute it. To give you an example, right? Um, I don't know, like in Dhaka, right? You take any app, right? You go, I don't know, you go to like a cell phone booth, right? Or a cell phone office, right? With any problem, what do they ask you first, right? Probably your cell phone number, first name or last name, right? And they put it in a form, they look up. So behind the scene, it goes to the database, said, give me details of this account, whose account number is this, and last name is this. Next time someone else comes, they do the same thing. So it doesn't have to go through the same because it's always looking up query to the database. Now, the problem is what happened when the cardinality estimation is wrong. And I'll talk about why the cardinality estimation can go wrong, right? So say your query qualifies for 10 million rows, but the cardinality estimated that it will only qualify for 1 million. What will happen? Let's look at this slide. So SQL Server, whenever we submit a query can run in a serial fashion or in parallel fashion, right? How does SQL Server decide? This query can run in parallel or not in parallel um, based on the cost. Plus, there are some other settings like max drop and cost threshold. Those of you who administer SQL Server, I'm sure you saw this, these settings. So if your estimate is wrong, if there was 10 rows, I should have probably run this in parallel, but my estimation was 1 million. So now I'm going to choose a serial plan. So what happens now? Instead of using 4 or 8 schedule or CPU, I'm just now using a single thread and the query is going to run slow. Memory grant can get affected. So say like I needed 10 meg of memory to, but I only got allocated 1 meg. So what happened now? My sort, instead of doing it in memory, the sort is going to happen in tempdb. So now I'm going to the disk. So I'm writing all this data in the disk, I'm sorting it, and then I'm reading it back to the memory. So you are comparing really microsecond versus millisecond. Now your query is again slow. How do we access a table? Do we do a seek scan or a seek plus scan? All these things depends on your estimate. So if the cardinality estimator estimate wrong numbers, everything is going to affect it. Eventually your query is going to run longer. And when your query runs longer, what will happen? Your throughput is going to go down, right? So, somebody was talking about, the speaker, Shahjan Bhai, I believe, they created an app. So I don't know, like he said, like 200,000 users at the same time using it, right? You want them to come to your app, get the data and get out, right? You don't want them to run for longer because if they run longer, they're holding CPU and memory. Now your concurrency is going to get affected, right? Other users cannot get in because there is not enough scheduler available for them to get on the CPU. Your algorithm, right? So the join, SQL Server does 3 different kind of join: physical join, nested loop join, hash join, merge join. Again, depending on those cardinal estimators. So what I'm trying to say is that phase is very important. So now, why those phases can go wrong, right? Why does cardinality estimator cannot estimate correct number all the time? In SQL Server, there's something called histogram. So whenever you create an index, SQL Server also creates statistics. And for each statistics, there is a histogram. And most of the time, if you have an index, SQL Server will go and look at the histogram and try to estimate the number of rows. So histogram is only have 200 steps. Doesn't matter how big your table is. Your table can have 1 million rows or 100 million rows, but histogram cannot get more than 100 steps. Our statistics can get uh, stale. And what I mean by that, so you updated your stats right now, then you start doing update deletes in your table. For every insert update delete or every modification of rows, SQL Server does not update its stats. It's just not practical. So the more data you modify, the more stale your statistics gets. Plus, historically, there are some data structure that we use like table variables, user-defined functions. Microsoft did not really tackle this structures in terms of cardinality estimation. So Microsoft hard-coded these numbers, like for table variable. Pre-2012, pre-2014, if you are using table variable, the cardinality estimator will always estimate one single row. Doesn't matter, you can put 1 million row in your table variable. um, SQL Server query engine has no clue. It always estimates one, and we'll see some of these things during the demo. So what happened in 2017, as I said, in the adaptive query processing, Microsoft introduced the things that I circled with a blue color. So adaptive join, execution, and memory grant feedback. In 2019, the things that I circled in light green color, those are the things I added in 2019 with the release of 2019. And then all together, they call this intelligent query processing. And these are the features that's included into this intelligent query processing. Now, I know some of you are probably using Azure SQL database. Out of this, there's one feature called T-SQL scalar UDF inlining on the right side on the top. Except that one, everything else is also supported within Azure SQL database. Uh, and yeah, so let's move on. This is one of the system catalog view. I just wrote the name and I'll show you how to use it at the end. I want you to take a note of this. In case if you have upgraded to SQL Server 2019 and you upgrade your to 150, but you do not want to use one of these features, say like out of these 7, you do not want to use a particular one. There are some hints that you can use at database level to enable or disable those features. So it's good to know, because you might have a database that for I don't know, for any reason you might not want to use that feature in that database. You can disable it. There is another one. It's a system DMV. You can use this one to disable or enable some of these features at a query level. So once you upgrade to 2019, you can control these features at a server level, at a database level, also at a query level. Say for some reason, I don't know, say like you have a query that everything else is running fine after you upgrade to 2017 or 19, but you just have one or two query that's regressed. They're having bad performance than your previous version. You can go and use the hints, and if you go to this DMV, there are exactly 23 hints that you can use within your query. So moving forward, all my slides will have these three symbols. I kind of put some labels on this so you know what slide you're looking at. So if you see, the left side have this symbol. So if you see one of the symbols, that slide is talking about a problem or a solution or a couple of cautions or notes. So like this one has a, if you see that symbol on the right top corner, it's talking about, what problem Microsoft is trying to solve with this. So, and if you see these numbers that I put on the left, 140 or 150, these are compatibility levels. So in 2017, the default compatibility level is 140. For 2019, it's 150. Now, some of you might ask me that why I did not put SQL Server 2017 and 2019. Instead of that, why did I put these numbers? The reason I put these numbers is Microsoft is pushing heavily to use compatibility level. They are even telling their ISVs or their vendors to certify their product for compatibility level and not for SQL Server versions. Why? If you go to cloud today in Azure SQL database, there is no way you can say, I want to go to 2017, 2019, or 2016. You have no control. There is no major version in cloud. They call it version 12. But the way you can mimic your on-prem SQL Server behavior in cloud is controlling your compatibility level. So even in Azure SQL database, you can change the compatibility level from 100 to 150, but you cannot say I'm in 2019 or 2017. That's why I put those numbers. So let's move. We have only 35 minutes left, so I'm going to move very quickly. Asan bhai, any question at time? No, okay, so I'll move on. Okay, so the first one is adaptive join in batch mode. Problem Microsoft is trying to solve. So take an example say in Bangladesh, you have a database for the whole. Now you rebooted your server, someone come and submitted a query for a smaller city or for a smaller district, right? And then that query get compiled, it get a plan, the plan get into cache. Next time someone come and submit that same query with a different parameter for a big city like that. Now your previous query only qualified for a small subset of data. Now you are submitting the same query for a bigger set of data. The query is already cached in the plan. Now you are using the same query plan, right? So that's the problem, because now, because the query is already compiled with the parameter that qualified for a smaller subset of rows, and now you are using the same query for a bigger set of data, you're going to get less CPU, less memory, and different type of joins, right? So I don't know if you guys know, like how a nested loop join works. In a nested loop join, always get a single row from your outer table, and then for each row you go to your inner table and you do your join. Now if you have a huge number of rows, nested loop join can be very painful. Your query might be running for hours and hours. So now with adaptive join, on the fly is going to decide if I'm going to do a nested loop join or I'm going to do a hash join, looking at the outer table, and it will have a threshold based on the is going to decide on the fly. And this is only in 2017 and 2019. You do not have to make any changes in your query. How does it do that? So if you look at this graph, and I also put a link at the bottom. If someone is interested, you can read that paper. So it will come up with a threshold, and based on the threshold, if you're above the threshold, it's going to do a hash join, and if you are below the threshold, it's going to do a nested loop join. Basically, if you have a less number of rows, you get a nested loop join, which is ideal. If you get a large set of rows, it will go for a hash join. This is only going to work for select statement, and both join, of course, have to have the same outer reference. So I'm going to move on to the next one. Table variable deferred compilation. So table variable, if you use, it was always a pain from statistics wise, because SQL Server only number one. So it doesn't matter. You can put thousands or millions of rows into your table variable. You can insert, but the query optimizer doesn't have any clue how many rows are there, because compile time, SQL Server doesn't see that. The query optimizer cannot see how many you enter. Um, it always estimate that it's only one row. Um, Table variables are not like temp tables. It doesn't have any statistics. It doesn't create stats automatically, and also you cannot create like you create a temp table, and then I can create an index on the temp table in a separate batch. With table variable, you can only create index when you are declaring the table variable, not outside the definition. So these are some of the problems that they're trying to solve. So in 2019, if you have a table variable, SQL Server will delay the compilation till you do the insert. So once you're done insert, then SQL Server will compile your query. Then, because now it can see that how many rows you have inside the table variable, and based on that row, as we discussed, SQL Server can do the other part, like now the estimates is going to be correct. You are going to get the right amount of resources allocated for your query to execute. So that doesn't change the other characteristics. Like I said, it's still not going to have a column statistics, and this does not solve your parameter sniffing problem, because the first time your query get compiled, save that plan in the cache. So next time you come and you insert a different number of rows into the table variable, but again, it only do it for the first time. Multi-statement table value functions. So this was another problem similar to what I just talked about with table value. So up to SQL Server 2012, it will always estimate one row, from 2014, they changed that number from 1 to 100. Still, you go through the same problem, right? Because your function can qualify for a large set of rows, but the cardinality estimator see that. Uh, so again, what it is going to do, it is now it's going to take that table valued function, and it is going to recompile, and so it can see that exactly how many rows it's qualifying. So your actual row counts are going to be used instead of that estimate of 1 and 100. So you will get a better execution plan. Again, you do not have to change your code. If your database is using a compatibility level or 140 or 150, you get this features automatically. And I have demo for each one that I'll show you. Um, Memory grant feedback. So this was a big problem for SQL Server. Like I explained during in the slide, that your query was getting compiled. You estimated 1 million rows, and you got a memory grant for your sort or for your hash table. Now during the actual execution, it sees that no, it qualifies for a bigger number of rows, and previously SQL Server did not adjust it, right? So if you are compiling that same query, sorry, you are executing that same query over and over, SQL Server had no way to adjust that memory. So if you had a sort spill to 10 dB, you execute that query 1,000 times, it will get that spill 1,000 times. So finally, Microsoft said, hey, if I see a spill, why not adjust the memory on the second execution on the fly, right? So first time I saw that, I gave you X kilobyte of memory. I saw a spill. Next time I'm going to adjust it. And it's vice versa. So SQL Server granted you 10 meg memory and you only used less than half of that. On the next execution, SQL Server will reduce your memory grant. So other queries so SQL Server can distribute that saved memory to the other queries. So it works on both way. And there is a formula for that. If you see in this slide, when does a recalculate trigger? If SQL Server see a spill warning, or it says that whatever memory was granted, it is greater than twice the size of actually used. If you hit any of these two threshold, on the subsequent execution, SQL Server will adjust your memory. And in Management Studio, there's a new property called memory grant feedback. SQL Server, you can go and check it yourself if your query is adjusting the memory grant feedback, on that execution, and I'll show you that. For that to see, you should use the latest version of Management Studio. And as a side note, just for everyone whoever works with SQL Server, I have a strong opinion about using Management Studio, the latest version, because I see no reason why you would use a older version. Because on the newer versions, Microsoft is releasing new properties which are very helpful, especially if you're tuning your query. So I will highly encourage everyone to use latest version. The current one is 18.6, and you can download that for free. You even do not have to give your email address. There are some restrictions on the memory grant feedback, like if it's under 1 meg, it even doesn't look at those. The query store, if you are using store from 2016 and up, this is not saved in query store, so you really cannot see if your query actually qualified for a adjustment or not. It's not yet, but I think very soon they will do that. Other thing, if you are using resource governor to memory and CPU, this will honor that. So even though the memory grant feedback thinks that it should give it a certain number, certain amount of memory, but if that is more than what's allowed by the resource governor, Microsoft or the query engine is going to honor the limit set by resource governor. If you're using, there's a new feature called batch mode on row store. So if your qualify for batch mode, you'll also qualify for memory grant feedback, just so you know. TC scalar UDF inlining. So scalar user defined functions. Uh, so if anyone doesn't know what TSQL scalar UDF, it's a function that's written in TSQL that return a single data value. We call those TSQL scalar user defined functions. That's kind of the official name. So functions are good, right? Because you can write a big piece of code once, and you can use that over and over, right? So you can encapsulate your logics, so you don't have to write that piece of code every time. You can use a function against every rows in a table, or you can apply do it in a cross apply or whatnot. But there are also some problem with user defined functions, because user defined TSQL defined functions are really not set based. So SQL's the TSQL is really a set based language, but user defined functions are iterative. So if you are calling these functions for a 1 million, if you're doing a cross apply with a table of 1 million, it is going to be executed 1 million. There's no concept of set based. SQL Server cannot estimate the cost of running a function. SQL Server has no visibility. It cannot go parallel. So there are a bunch of problems with the user defined functions. So finally, Microsoft decided what it is going to do. That it is going to take the code of the function and inline it within your your store procedure or your TSQL code, and optimize the execution plan. It's based on the Freud framework. I put a link there if you want to read more about it, how they did this. But one caution that every function is not going to be inline. There are a lot of restrictions because this is only the first release. I think they're going to keep improving on this one. So but if there is a particular function that you do not want it to get inline for some reason, you can use those hints that I talked about, but you can also use this piece of TSQL code that I'm showing in my slide within your function. You can hard code this into your function. And if you do that, say if you say inline equals off, SQL Server will honor that, and it will not inline that particular function, even though you are in 2019. Batch mode on row store. So batch mode was first released in 2012 with column store index. Because of saving your CPU cycles. So instead of looking at row by row, batch mode looks at about 900 rows at a time, and it gives huge efficiency if you are dealing with large data set. So the community has been asking for the same feature on row store for many years, because column store index is something you cannot go and implement in every place, right? It has its own restrictions. So like if you have a trigger, if you have a cursor, if you have a persistent column, like you cannot use column store index. And column store index is really not for everything, because you also have some restriction on indexing. So finally, Microsoft released batch mode on row store, and it's a huge gains, um, uh, because now you'll be looking at about 900 rows in a batch instead of a single row. So it's a huge CPU. You're not going to save on IO. I just want to make it clear. If you really have a problem with IO, that you are doing a large number, you want to look at column store index. But what batch mode on row store is going to give us is to save CPU cycles. Again, there are some restrictions, like if you have an XML column, sparse columns, it is not going to qualify for that. In memory world, TP doesn't qualify for that feature. Approximate count distinct. So this is something not really into the querying, and this is not for everybody, right? If you're working in a bank, don't even look at that, right? Because you do not want your bank account to get approximate numbers, right? You exact, amount of how much money you have in the bank. But if you're working with like a dashboard scenarios, or if you're looking at trending, over time, you do not need exact count, right? So you can do approximate count distinct, and it's huge saving on your memory use, and we'll see this during the uh, again some caution that um, be careful if you're using this. If someone need the exact number, do not use this. And this feature is based on an algorithm called hyperloglog, and I put a link if you want to read about that. Microsoft guarantees, or Microsoft's official term is you get 97% accuracy with a 2% error rate when you use approximate count distinct. So if you want to disable this feature, this slide shows you how to do that. You can do a database level. The first two examples in 2019, they actually changed some of the names. So that's why I put two different examples there. And if you want to disable any of these features at a query level, then look at the third section here. And I just gave an example about memory grant. But if you go to the DMV that I showed at the beginning, and there are hints for each of these features. I'm going to go to demo. I know I rushed through this because of the time constraint, but I'll take question and answer at the end. I can hang out in the chat room. So let's demo. I'm using 2019 CU6, and I'll be using Management Studio 18.6. Asan bhai, can you see my Management Studio?
No, I think it's still the slide is open.
Slide.
PowerPoint presentation is open still.
Okay, so that's not good. How about now? Can you see the? No. Okay, let me stop. Open share tray. Hmm. Okay, can you see now?
Yes,
Yeah.
I can see it.
Okay, so I see someone asked a question. Does SQL Server support parallelism for query execution? Absolutely. SQL Server does support parallelism for query execution. That depends on three things. One is the cost of the query. Your setting, there's two settings. One is called max stop, and another one is a cost threshold of parallelism. So I'm not going to go into detail, but if you have more question, just ping me on the side and we can talk about that. So let's move on. Also, someone asked, can you please talk a little bit about graph database in SQL Server? Big topic, so we can take it on the side if you have any question. Uh, okay, let's move on. So, okay. So when you get my code, it's in GitHub, you can download and use it as you need, like I said, because we only have 16 minutes. I might not get through everything. So before all of you came online, I did run this setup code and I put enough comments, how to set this up. So I'm not going to run this again because it takes about 10 minutes and you don't need to see this. But you can download this from here. It's a Microsoft official download, and then you run all this code in your, in your test machine. Once you do that, then you can go through, my demo code. And for each one, I pretty much downloaded these codes from GitHub, from Microsoft's website, from Microsoft's repo, and I made some adjustment. So I just want to make sure that I make it clear that I did not write all this code from scratch. But I made some adjustments. So let's move on. Let's and each one I have a name, so that will tell you, what you're looking at. So adaptive join in batch mode. So for each one, you'll see that I'm changing my compatibility level here. And what does that do? Even though I'm using SQL Server 2019, once I run this compatibility mode change query, what it's going to do behind the scene is going to act like 2017. That's why please read on compatibility level. This is a very strong feature that, without changing so many things, you can make your queries uh, act in different way for different versions. So if you have a query, if you have a regressed query, you can use this to fix some of this stuff instead of touching your query. And then I'm going to clean the cache just at a database level, just for demo purpose. And then all of this, we're going to be looking at execution plan. And if you do not know how to look at execution plan, um, you might not be able to follow some of this stuff. But if uh, and if you're working with SQL Server, I'll request you to start, or I'll just urge you to start looking at execution plan. Unless you understand execution plan, it's hard to uh, do any performance tuning, because if you don't know what is happening inside the query, you wouldn't be able to. So you can turn on execution plan by actual execution plan. There are two different type. One is estimated and one is actual. So look, Control M, or you can push this button. And now run this query. If you see this adaptive join, this is something new in 2019 and 2017. SQL Server didn't had this before. So what this is telling us, if you see here on the, this is my top table, but at the bottom I have two different branches. And on this one, this time it got executed with this one. As you can see, it qualified for 672 rows, but this one is 0, so it didn't do anything. And if we go here, if we look at the tooltip, it says it's an adaptive join, and the actual join type is a hash match. And we have a threshold 68. So what happened here? We qualified for 206 rows, and our threshold was 68. So SQL Server choose to do a hash match join. And we'll do the same query. Here we pass 360, right? What are we going to do? We're going to force it. We're going to do some insert with 361, but this time we're only going to insert 5 rows just for demo purpose. Now look at this. We will be running the same query with 361, and here we did the same query with 360. And look at what happened this time. Because we have 5 queries only, the same query, and it's using the same query plan from the cache. It is doing a nested loop join. Why? Because this was our threshold and we qualified for 5, which is below the threshold. Now on the fly, SQL Server decided to do a nested loop join, and the query didn't get compiled. As you can see, this still has a branch for hash join, has a branch for nested loop join, and we didn't had this feature before. Run this query in an older compatibility mode, you will see that for both it will do the hash join because the query was first compiled with the hash join. One thing to notice here on the top table, this was a column store index, and SQL Server did a batch mode scan. But this feature also qualifies for row mode. And I'm just going to give you an example here. Okay, I had to run some sorry, I had to run some test code that I did not run for this, but when you do your demo, you can try that. So okay, next look at table variable deferred compilation. So we are in 140, which is same as 2017. Turn on the actual execution plan. So we declare a table variable, we do some insert, and then we do a select from there, right? Let's close this. What are you going to see? We'll see that estimated number of rows are 1, but actually is going to qualify for. So look at this. So this is a problem I'm showing. I'm still not showing you the solution. Oh, sorry. Minimize this. Okay. Look at the estimated number of rows. 1. Actual number of rows is 500,000 rows, right? 490,000. So what happened because of that? What I was talking during my presentation, we have a spill to TempDB because we are only given 544 kilobyte of memory more. So yeah, it gave us 1632 kilobyte, which is probably not enough for 500,000 rows. Now, I am not changing my code at all. I'm just bumping up the compatibility level to 150, means I'm saying now SQL Server 2019. And I'm running the exact same query. As you can see, I did not change a single thing. Happened this time. Look at this now. We got parallelism and look at the estimated number of rows and the actual number of rows matches because it did a deferred compilation. There is in our sort, there is no spill warning. Why? Look at the memory grade. Instead of 1600 something, now we got 124 megabyte. And all this happened without any code change. We only have 6 minutes, so I'm not going to be able to show all. Let me show you the memory grant one. And you can download and test this by yourself and send me questions. So I'm doing the same here. I'm just creating a store prog just for demo purpose. So call this store procedure that I just created with 2 different parameters at the same time. And we'll see what happen. So on the first one, you can see there's a warning. It says it detects a excessive grant. Why? SQL Server gave us 67 megabyte of memory and used 920. So on the next execution, SQL Server adjusted memory, but then it So a different problem. If you go and look at the properties under the memory grant, it says I'm adjusting, right? But that adjustment was also wrong because, as you can see here, adjusted too low because now we have a sort warning. So not enough. Now if I go and execute this query again, so first it says I gave you too much, adjusted. Now it says that I gave you too less. So let's do it for third time. Look at this. There's no warning. Adjusted again, right? And if you go to the properties, still adjusting. So if I run this at a fourth time, and it should say that, I'm done with adjusting. And yes, okay. Yes, stable means I'm not going to adjust anymore. I'm done, right? So this will be the fixed amount going forward. Okay, so we only have 4 minutes. So I'm not going to show you any other demos. I have this. So you have to, test this by yourself after you download. So, so shared window sharing is paused. Oh, it says sharing is paused. I'm not sure what happened. Um, okay, so I'm just gonna, I don't know if you can see my slides again. So there's resources that I added, uh, that you can read more about this. And I'll just look in the chat. There are questions.
So, but there is a question that what is the better between table variable and temporary table?
Yes, okay. So table variable and temporary table um, itself can be a 1 hour talk talking about versus table variable. I'm not going to give a yes no answer because it depends. It depends.
Right.
Both has use cases. You have to know the features, right? You have to just know how these things behave, how a table variable behave versus a temp table. So I'm not give a yes or no answer because that won't be fair. But if you have a particular use case, definitely I can, probably give some guidance. And so I know I through this because of the time. So thank you very much. We have 2 minutes. Asan bhai, I can take questions, but I'll hang out in the chat room.
Okay.
Long as people can ping me personally. I think there's a feature you can just go to my picture or whatever you see, and you can right click and say, send a message because I'm respectful to the next speaker. Make sure, he or she can start on time. So I'll
Okay.
pause here. I'll send this slide deck and all demo code to Asan bhai so he can